ReasonConf is brought to you by our gold sponsors Ahrefs and Chain Street.
Morning, everybody. So I mentioned a little bit yesterday that I had this AWS Lambda runtime for OCaml, which I'm very excited about, and I'm going to be talking about that a little bit. And so I'm going to be demoing an example that uses AWS Lambda, HTTP2, OneGraph, and Now.sh. And I do know that like all the buzzwords are included, so we're going to be seeing some of that. If you want to follow along this presentation, it has some links at the end. You can go to this link. Feel free to take any pictures. Okay, so to give kind of an introduction, AWS Lambda is so this service that lets you run your functions as a service. And up until I think last November, end of November or something, they only had like a limited number of runtimes which they supported, and this included I think Node.js, Python, Java, PowerShell for some reason, so at the end of November, they launched this custom runtime support. So they opened up their I think their I'm sure a REST API that lets people write their own custom runtimes against this API, which is basically something that will just poll for events, execute the user's function, and post the user's function's response to their API, and this makes possible to write any language on AWS Lambda right now. So yeah, I wrote something for OCaml and Reason because I wanted to use OCaml on AWS Lambda. And in the example that I'm going to show, we're going to use GraphQL PPX on the native side. This is all native. Like there's no compilation to JavaScript whatsoever. So we're going to use GraphQL PPX on the native side to query the GitHub API over GraphQL through OneGraph, which is a service that wraps many APIs into like a single GraphQL endpoint. We're going to do this over HTTP2, over an HTTP2 implementation in OCaml that I also kind of wrote. And we're going to produce a response from the Lambda function and deploy a Lambda function that is deployed in AWS through Now.sh. And this is all from native Reason ML. So we're going to see a demo, or I'm not actually going to code this, but we're going to just see a walkthrough of the example that I prepared, if I manage to know how to do. There we go. So I know this is a little bit tiny. How's this for the people in the back? Awesome. Okay, so basically, this doesn't matter. Basically, at the simplest thing that we need to do is call this now.lambda.io lambda with a function with a handler, and a handler is any kind of code that you would already write that needs to match a certain signature. And so in this case, it just needs to match the signature that you see down here. So it takes a request, a context for that request, and it just needs to produce a result type of a now response. And if we dig a little into that, well, actually can't see that right here, but yeah, so the request would be something like, right now it's just a record that takes a path, an HTTP method, the host, some headers, and a body, which might be empty. And from this, we just need to, so in my case, the application, what the application does is it's going to query the GitHub API about a specific repo, take the number of stars and the stargazers, and show like the first whatever you specify. And so in this case, we wrote a GraphQL query using GraphQL PPX. If you've not ever used it, just go to the README. It has some nice documentation. It's also really nice library to use because you dump a GraphQL query in here and generates a function for you to construct that query with some variables. So as I said, we're gonna like take the stargazers of a specific repo along with like their login avatar and like name, the total number of stars. We're then gonna, so this gets the GraphQL response. I'm gonna run through this really quickly because what I want to show is the end result. But so we're gonna send a post to OneGraph. We get the response. We parse the thingy, the response. There's a lot of like option types here and like lots of switching. This can be done better with some libraries, but I just want to do the bare minimum. So in this case, we're gonna get the stargazers, construct our own record types, and return that to a function that is gonna handle the results and just send a response. This is using a library called Camel on the web, which is part of the Mirage libraries. So what this does is just it builds some HTML for us, and then we're going to return that to the client. So in the send response function, we're actually doing sending just a response record. This API can be made better. This is just a proof of concept. And so yeah, we're just sending a response with a content type HTML such that the browsers know how to render this. And I don't know if I made any changes to this, but we can say, I wanted to kind of deploy this live. So we can say stargazers or I don't know, just add some text in here so that you see that I'm not like faking anything. We can do live from ReasonConf. There we go. So what I'm gonna do right here is, oh, okay, wait one sec. There we go. We're gonna do, there's like a build script. Oh, I need Docker. Why do I need Docker? AWS Lambda runs Linux, and I need Docker because I'm on a Mac, and I want to statically compile and statically link my Lambda such that AWS, because AWS Lambda has like these non-standard paths for libc and like all these weird things. Their environment is kind of weird. Docker is still not available. Wait, what? Build.sh. Okay, and so that's why we just, to make it easy, we just statically link everything, and so everything is inside the binary that we deploy, and we don't need to know about any of the stuff that, like where the things are, or the libraries are in AWS Lambda. And so what this is doing is, this is using a tool called Easy to fetch the OCaml dependencies, build a local sandbox of all these dependencies for my project, and build our code using this build tool for OCaml called Dune. And then after this is done building the Docker image, I'm just gonna extract the binary that we built out of that to my local computer, and I'm gonna run now and deploy that to the Zeit service. While this is building, I can take any questions if anybody has them.
What's the code start time?
Yes. So the code start time for so the question was, what's the startup time for the natively compiled lambdas? And I think it starts up in about 20 to 30 milliseconds, and the Hello World example for OCaml runs in about 1 millisecond. Which is, I guess, not much. Okay, so this is almost done building. And this is just building all the dependencies that I need for my project, that Easy resolved. And now it's gonna eventually build my project itself. I don't know exactly what we're waiting on. I certainly hope it's not OpenSSL, because that takes a little while.
Oh yeah, they block.
No, it's fine. Okay, so this is now actually building our Lambda with the Dune profile of static so that it can be statically linked. This is something that It could be called something else. Just specify the flags. And now, actually, this generates a file called Bootstrap. I'm going to remove it from here and verify that it's not here. And I'm going to run build again. This is going to be really fast now because the thing is cached by Docker. And so the Bootstrap file is here. So what we're going to do is we're going to deploy this to the Brussels region of Now, because yesterday the other region was having some trouble, and I want this to work. So this is uploading our statically linked binary to their platform, and it's going to build a Lambda out of this. And they have this new concept called builders, but what this really does is just it's because it's just a statically linked binary with the runtime in it. It just compiles that, copies that, moves it to a Lambda. That there's nothing needed to be done here. And so in this case, it generates an OCaml Lambda of like almost 3 point something megabytes with all the dependencies in it, which I think is pretty good. So this generated this link for us, and we're gonna go back to our browser and try to see if our Lambda works. So this, in this case, I'm gonna say, I think AWS Lambda OCaml runtime, and I'm gonna get the star summary for that. This is live from ReasonConf, and so there are 74 stars in this repo, and these are the, thank you. These are the last people that started the repo. We can do this for any repo, and like we can just get, you know, like the last person to have started the repo. So that's all I had. There are some. Thank you for listening. There are some links here, but as I said, there's the, if you've I'll show you this again. So if you want to get the links, feel free to go here and go to the very last slide. Yeah, thanks.
Awesome.